everyone. Thanks very much for joining us for the simplest security steps on AWS. I'm Phil Rodriguez, head of the security team for AWS in Australia and New Zealand, based in Sydney.
Hi everyone, I'm Sarah Gray, Enterprise Solutions Architect for AWS based in Canberra.
This talk will show you what we feel are the easiest and most effective steps you should take to secure your AWS environment. This talk is aimed at everyone that uses AWS. New customers, existing customers, large customers, small customers. This talk will help you, no matter if you're the biggest bank in the world or the smallest startup. If you're a developer with years on the platform, or the chief information security officer of a company that's just starting to move into the cloud.
Today's talk is distilled from the practical experience of the AWS security field teams. We work with customers every day to help them understand how they can reduce their risk by improving the security of the workloads they run on AWS. Phil and I have spoken with hundreds of customers about these topics, and these are the essential things we want you to do now.
Today we're focusing on security steps that will help you protect your AWS environment, or what the industry calls protective controls. Yes, there are more things you can do for even more complete security coverage, but we'll save some of those things, like how to detect suspicious activity, for another talk. This is an important topic. We want you to listen, and more importantly, we want you to take action now. It's a 30-minute talk, but following all of these steps in one AWS account will take you less than 30 minutes. That's right, you can secure your AWS environment in less time than it takes to watch this talk. You're watching this online, so if you want, go ahead and open up a browser, go to the AWS console, and go through these steps with us now. So let's get started. And let's have some fun. The story we're telling today is about Julie. Julie's used AWS for about a year, and she uses the cloud to run a web application for her small business. She's got a technical background, but she wears many hats, and she needs to move fast. Julie loves AWS because it's so easy to do so many things, which saves her most precious resource, time. So we need three things to tell this story. First, we need a main character. Well, you already met Julie. Second, we need an environment.
I set up this simple architecture for my business. I run a popular website of dog pictures, which I have turned into a business by connecting potential dog owners with dog breeders and offering a subscription package for special access. My customers connect to an internet-facing Windows web server that I installed on EC2, AWS's virtual compute platform. The EC2 instance is inside of an AWS Virtual Private Cloud Network, or VPC, and attached to the Internet Gateway. I maintain my directory of cute puppies and my customer details on a database, and I choose Amazon Relational Database Service, or RDS, using Microsoft SQL Server. My customers are great, but I'm occasionally interrupted by people that try to upload cat pictures to my website. So I added an additional feature that automatically analyzes new images to confirm they are lovely dogs and not nasty cats, powered by Amazon Rekognition. Once the machine learning confirms it's a dog picture, the objects are stored on Amazon Simple Storage Service, or S3.
This is a simple example which covers all the areas that we'll highlight today. Yes, your environment might be a little more complex, but the simple security steps we're covering today will work equally well for you. One last thing, Julie likes to move fast to stay ahead of her customers. However, in this example, Julie was moving a little too fast, and she didn't do a few simple things to secure her AWS environment. Don't worry, we're going to help Julie find and fix these issues, but we need our third and final thing, something that can help her. Let's see, maybe a magic wand? Or a magic scarf? No. Those things are not real. This isn't fantasy, this is reality. She needs something that's based on good, sound scientific principles. She needs a time machine. Perfect, that's everything we need. Let's keep going. Wait, number 6. Oh, right, we're going back in time in that time machine. So we're going to count down the simplest steps from the last to the first. So let's start with number 6. Go for it, Julie.
I use Amazon Simple Storage Service, or S3, to store my customers' lovely dog pictures and also for the static content on my website. I want a lot of people to visit my website, so I made these objects public so everyone can see these great graphics and read the text. I also use S3 to store other objects, including non-technical things like internal documents or technical things like backups. I should put these in a different bucket, but I haven't gotten around to it yet. I'm sure I'll do it soon.
She never did. S3 is a great service, and it's secure by default like all other AWS services. People use S3 for many reasons, including the sharing of public content, and Julie is right for using public objects or a public bucket to share her public content. However, it's risky to allow public access to private content. Unfortunately for Julie, an external person accessed one of her private documents because she left this sensitive data in a public bucket, and now the source code of her website has been revealed. Not good. Lucky for Julie, she's got that time machine.
Oh my. Here I am, back in 2020. Not a great year to revisit. But why am I here? Right, restricting public content. I'm going to protect my sensitive data with the right controls on S3. Amazon S3 is an object storage service that is built to store and retrieve any amount of data from anywhere. I use S3 to store different objects within the same bucket. That bucket is public because that is where I keep all the lovely dog pictures for my website. But next to that public content is private content. I'm going to create a new bucket to store my sensitive data. New buckets on S3 default to block public access, which means the bucket and the objects in the bucket cannot be accessed publicly. You can also apply block public access to existing buckets and even to your entire account. I will name my bucket something obvious, like private. It only takes a few seconds for the new private bucket to be created. Now let's get those files in the right location. Rather than trying to move the objects or change the permissions, first I'm going to download my content, and then I will be extra careful and delete the sensitive data from the public bucket. Yes, that looks right. Now it's only the lovely dog pictures in the public bucket, and I want the whole world to see those dogs. Moving back to the private bucket, I will upload my sensitive files. An object inherits the permissions of the bucket it is put inside of. If I upload a file to a private bucket, then that file will be private. I should double check to make sure the file has the right permissions. Yes, the sensitive data has the correct permissions. Everyone does not have read or write access to my sensitive data. That's a much better configuration. It's easy to use public and private buckets on S3.
Great work, Julie. That's simplest security step number 6, restrict public storage. Use S3's default setting of block public access for new buckets, or apply block public access to existing buckets that you want to keep private. Now remember, we're starting off with number 6 and working our way backwards. This is a time machine after all, so let's take a look at step number 5.
I needed a web server for my site and decided to run the default web server on Windows. As you know, I'm using Amazon EC2 to run my virtual instance, so I selected a Windows image and chose the default options. Once it was ready, I logged into the operating system and configured the web server. I got my site running and then left everything else as the default. Looks good.
And things did look good for Julie for a few months. But every month her operating system needed new patches, and she did not realize that she needed to keep it up to date. Unfortunately for Julie, she was impacted by ransomware, which took hold of her system, locked the files on her operating system, and brought her site down. Not good. Lucky for Julie, she's got that time machine.
Let me guess, 2020. Yep, I need to make sure I have visibility of vulnerabilities in my environment, and that I have the tools I need to continuously deliver patches to my operating system and other resources I have installed myself. Amazon Inspector is an automated security assessment service that helps improve the security and compliance of applications deployed on AWS. I used an Amazon machine image as the base of my operating system, which meant I was able to get Inspector set up quickly. It only takes a few clicks in the console to select the type of scan and the scan target, then the assessment takes a little while to run. The scan is complete, so let's check the results. 862 findings. Good thing I'm doing this now. I can dive into these results later. The most important thing to do now is to get these issues fixed by patching them. AWS Systems Manager gives me operational insights and allows me to take action on a number of AWS resources. Again, because I'm using the AWS recommended operating system image for my EC2 environment, getting Systems Manager set up is really simple. It just takes a few clicks. The compliance view shows my host needs some patches. I only have one instance running now, but you can imagine the convenience of seeing the status of hundreds or even thousands of instances running in a larger environment. In Patch Manager, I select the default baseline for Windows, but as you can see, Systems Manager also works on Amazon Linux, Red Hat Linux, or many other operating systems. One more click to tell Systems Manager to go ahead and install those patches. Note I'm using the Compliance and Patch Manager views, but Systems Manager has many different features. Applying those patches does not take long. Back in the Compliance tab, I can see the host is green. Systems Manager installed the 154 patches my system needed. Amazon Inspector plus AWS Systems Manager is great combo to keep my EC2 instances patched and up to date.
Great work, Julie. That's simplest security step number 5, apply patches. Use Amazon Inspector to see what patches are needed and AWS Systems Manager to remotely and automatically install patches on resources that you manage. Okay, let's take a look at step number 4.
I chose Amazon EC2 to run my Windows operating system. I am responsible for managing the operating system. I choose to run on EC2, and I use the default remote desktop protocol. RDP needs a network port to communicate, and when I started my instance, it created a security group that allowed access from anywhere on the internet. The instance's primary function is to act as a web server, so I also opened up the web ports. That means everyone on the internet can access my website, which is what I wanted to do, right?
Wrong, or maybe half right. Julie does want everyone on the internet to access her website. That's her business model, and a busy site means more customers. However, she should only allow access to her web server on the web ports. She does not want everyone on the internet to remotely manage her server. That's something that she needs to restrict. But Julie did not restrict it. Somebody found an old password of hers and used it to log into RDP and stop her server. Now her site is down. Not good. Lucky for Julie, she's got that time machine.
Okay, 2020 again. Goody. I guess I need to do something differently. Aha, limiting network access. I will use Trusted Advisor to identify the VPC security groups that I need to limit, and then potentially use Systems Manager Session Manager to remove the need to open any ports. AWS Trusted Advisor is an online tool that provides a real-time guidance to help me follow AWS best practices. Some of the security checks are free to use. Trusted Advisor found an open network access, which highlights as a risk. It links directly to a specific security group that is the risk. A security group is a feature of Amazon Virtual Private Cloud, or VPC, that acts as a virtual firewall for my instance to control inbound and outbound traffic. I removed the open access to RDP 0000. Let's change it to a more specific rule for RDP that allows access only from my single IP address. Okay. Let's check that change before I commit it. This will remove the old open security group rule and replace it with a more specific rule. That looks good. I head back to Trusted Advisor to confirm it no longer sees the issue. Look at that. The check is all green. That's a simple way to confirm I have closed any open network access. There is an even better way to secure my remote access. I can use another feature of Systems Manager called Session Manager. Systems Manager is still set up from the previous step, and even if it wasn't set up, it's easy to prepare because I am using an AWS official Amazon machine image. I need to change one setting in order to use what's called an advanced instance tier, which allows me to run Session Manager. That's selected. So now I can open up the Session Manager tab. It shows a list of the Windows and Linux instances that I can connect to. Session Manager uses AWS IAM permissions to allow the AWS console direct access to the operating system that is running on the instance. I will run some simple commands to show it works for both Linux and Windows. The benefits of accessing the instance via Session Manager is that it doesn't require any open ports. If command line access is what you need, then close those security groups entirely. These three tools work really well together. My network access is a lot more secure.
Great work, Julie. That's simplest security step number 4, limit network access. Use AWS Trusted Advisor's security group checks to show your risky access, and configure your Amazon VPC security group to allow access from the entire internet only when absolutely necessary. Better yet, use System Manager Session Manager to eliminate the need to open any remote access ports. All right, now let's take a look at step number 3.
My website has interactive content. For example, visitors can tag their favorite dog pictures and my paying customers can personalize their experience on the site. To personalize the content and provide interactivity, I'm using a database. In this instance, I am using Amazon Relational Database Service, or RDS, which is communicating with ECS sitting on top of EC2. The ECS task definition or blueprint for my ECS containers is a JSON script of which I have hard-coded my username and password to make it easier for ECS to interact with services. That's how everyone does it, right?
No, Julie. Storing the password in plain text in your configuration file is not what everybody does. That password, also called a credential or a secret, is sensitive data because it allows access to the database. Unfortunately for Julie, whomever got a copy of her source code found that password, used it to access her database, and now they're emailing all of her customers. Not good. Lucky for Julie, she's got that time machine.
"2020, that year that never ends. There must be more simple security steps I need to complete." I guess I knew that my passwords in my configuration files of code was not a good idea, but I did know how to do it right. Now I see I should have been using AWS Secrets Manager to replace the insecure passwords in my code with secure references to protected secrets. AWS Secrets Manager helps me easily manage and retrieve database credentials, API keys, and other secrets throughout their life cycle. I will use Secrets Manager to manage the password that my web application on EC2 needs to interact with my database on RDS. I enter the username and password that I want to store, and then give Secrets Manager the name I want to use for the secret. For this example, I will keep all of the default settings. One more click, and the secret is ready to use. I'm now going to show you how I use the reference to the secret in my configuration file instead of the actual password. This will vary depending on your application, but the general principle is the same. I copy the resource name of the secret, which I will need in a moment. I'm running a container using Amazon Elastic Container Service, or ECS. My web application runs inside of that container cluster in what is called a task. Inside of this task is a section where variables are kept. One of those variables is the password for the database connection. First, I change the permissions to use the correct IAM role so that the container can communicate with Secrets Manager. Then I change the password variable itself. Instead of a clear text password, which would be risky if mishandled, I paste in the full resource name of the secret. Now, every time an application in the container needs the password to connect to the database, the container will securely retrieve the password from Secrets Manager. That's the best way to keep passwords out of my code.
Great work, Julie. That's simplest security step number 3, replace hard-coded credentials. Use AWS Secrets Manager to easily rotate, manage, and retrieve database credentials and all sorts of other secrets throughout their lifecycle. Okay, counting on down now to step number 2.
In my business, we only show pictures of lovely dogs, but occasionally people do try and upload a cat picture. I use Amazon Rekognition to analyze these images using deep learning technology that I do not need to train. The web application runs on containers on EC2, and that instance needs permission in my AWS environment to access Rekognition. I created an IAM user, then created an access key to allow my EC2 instance to access other AWS services in my account. I wasn't sure what permissions it needed, so I gave it administrator access, which seemed to work. I created the static key and stored it on the instance where no one could get access to it.
But somebody did get access to it. Maybe it was via the missing patch in the software that Julie installed. or via the open network access that she forgot to restrict. Regardless, it's against AWS practices to create these access keys and leave them on your system. Why? Because they last a long time, and if somebody else gets a copy of them, then they get access to the AWS environment with the same permissions as that key. Remember when Julie said she gave the key admin permissions? Well, this external party now has admin permissions to her environment. With this access, they started a lot of instances in order to mine cryptocurrency. Not good. Lucky for Julie, she's got that time machine.
"2020, how do I make this stop?" Okay, the right thing to do is to follow AWS's best practices and use roles instead of users. In the corner of the console is a shortcut that takes me right to my security credentials. That is the access key I issued for this IAM user. It's risky to leave the access key active indefinitely. Instead, I need to use an IAM role, which will grant access to AWS services with a specific permissions for a limited period of time. My application runs on EC2 and uses Amazon Rekognition. I will pick a role that will connect those two services. Read-only access is enough. I will make a name for that role that is obvious and easy to remember. Okay, the role is ready to use. Now I'll assign that role to my instance. In the EC2 section of the console, I find my running instance, which I named Lovely Dogs Online. With a few clicks, I can select the role I created in the previous screen and assign it to my running instance. That gives the instance the right permissions to access Rekognition. I test my application to confirm everything works properly. Now it's time to reduce my risk and remove that access key. I'm going to deactivate it for now so I can continue testing to make sure the role works properly. Later, once I'm sure I don't need it anymore, I can delete that access key permanently. I am now following AWS best practices by not using an IAM user access key.
Great work, Julie. That's simplest security step number 2. Use temporary credentials. Use IAM roles instead of IAM users and give those roles limited permissions for very specific functions. Check the My Security Credentials part of the console to see if access keys have been issued, and deactivate or delete those keys when you've fully transitioned over to roles. Okay, here we go. One last step to go.
My AWS environment is looking pretty good. All these simple security steps have helped a lot. I enjoy doing this sort of work on my AWS account. I just log on as root, enter my trusty old password, and configure the services I need. This is my extra secure password. It's my dog's middle name.
Sorry, Julie. Princess is not a good password. And would you please stop using your root account? It's got permission to do anything in your account. And while that's okay while you're first getting set up, we do not recommend you continue to use your root account for day-to-day access. And that password, where do I even begin? Unfortunately for Julie, somebody else guessed her password and took control of her account. Not good. Lucky for Julie, she's got that time machine.
"2020? I can do this. There must be one last step to get right. I need to stop using root and then protect access to all of my privileged accounts by adding the extra protection of a multi-factor authentication, or MFA. After I initially set up my AWS account, I continued to log in as a root to configure services and take other actions I needed in the console. That's risky because root has so many privileges. The first thing I want to do to protect this critical account is to add an additional requirement to log into it. Using a multi-factor authentication token is one option, or I can use my phone as a virtual MFA device. The setup is really quick. I just need to sync my phone's MFA application to my AWS account. The result is that only someone that knows my password and has access to my phone can log into this account, which is easy because I keep my phone with me all the time. I test this right away by logging back into my account. It asks for my username and password, and now it also asks for the additional codes from the MFA application on my phone. The second thing I need to do is stop using my root account. Instead, I'll create another privileged IAM user that I can use to occasionally do something important in the console, like configure a new service. Administrator access is one policy I can use. Once that account is ready, I need to protect it with MFA. same steps as before. I will use the same device this time, but I could use a hardware token like the popular Universal Second Factor or UTF keys. Remember, no matter what token you use, be sure to keep that token safe. Okay, looking back at these 6 steps, the thing that strikes me is just how simple each of them are. Each step only took a few clicks in the console. With my application in my environment, that took me less than 30 minutes. The AWS environment I configured is a lot more secure now that I have finished the simplest security steps.
Great work, Julie. That's simplest security step number 1, protect privileged credentials. Define specific IAM permissions for the things you want to do in your AWS account, and protect all of your privileged access with MFA, multi-factor authentication. These are the 6 simplest security steps in our recommended order. This is the order we want you to do them in. Number 1, protect privileged credentials. Number 2, use temporary credentials. Number 3, replace hard-coded credentials. Number 4, limit network access. Number 5, apply patches. And number 6, restrict public storage. We recommend that all customers, big and small, do these things now. These simple steps have proven to be an easy and effective way to secure your AWS environment. As you saw, none of them are difficult. They just take a few clicks. It took Julie in her environment less than 30 minutes to follow these steps. That's less time than it's taking you to watch this talk. So this talk focused on protection, which are the best steps to take first. For many customers, this will be the start of their journey, so where else can you go next? Well, we didn't mention any detective controls, things like logging and monitoring and alerting. Many of these steps are also quite simple. The simplest detection of all on AWS is to enable Amazon GuardDuty. This is a service that monitors your AWS environment and accounts for suspicious or malicious activity, and it sends you an alert if it detects anything. It's super simple to set up, just a single click in the console to get started. These steps are simple on purpose because we want you to remember them and we want you to take action on them now. For guidance on the rest of your security journey in the cloud, we recommend you follow the AWS Well-Architected Framework. It asks important questions about your cloud environment and, based on your answers, provides actionable guidance. Many of our customers, from the smallest startups to the largest enterprises, have embraced Well-Architected as an essential part of how they build in the cloud. We suggest you do the same.
We hope you enjoyed our story. Remember, Julie got lucky. She missed a few best practices, but she avoided getting into too much trouble because she had a time machine.
We want you to take the time to do these simplest security steps now. Implementing these effective controls will take you less time than you just spent watching this talk. Do you want to follow up on all these steps after the talk? Visit this website, which talks about all these steps, shows these videos, and links to labs with step-by-step instructions. Remember, at AWS, security is our top priority. Make security your top priority today. Thank you so much. If you enjoyed this video, please fill out the feedback form. Thanks.